Hello, my name is Balakrishna from Nim High School, and today me and my friend Sebastian is going to present about our research, which is droplet protection cover with polymethyl methacrylate and using polyethylene terephthalate filter.
Hello, my name is Sebastian. Polymethyl methacrylate is a physically durable, transparent, and light polymer compound. Because this homopolymer compound has a property which makes it easy to mold, scientists use a material known as acrylic sheets as partition that prevent the spread of viruses through droplets. Whereas the window tint that is used as a filler is a polyester that is infused with nanoceramic substance with properties such as high heat resistance, UV blocking capabilities, and good light reflection and high transmission power, so that by using a layer of window tint, the partition could absorb heat from its surroundings with high efficiency. The purpose of this research is to calculate the heat absorption, light reflection, and light transmission power of the droplet protection cover using polymethyl methacrylate and filter polyethylene terephthalate, and make a new type of droplet protection cover with polymethyl methacrylate and polyethylene terephthalate filter.
So the question that will be answered today is, does the droplet protection cover using polymethyl methacrylate and polyethylene terephthalate filter have a good heat absorption, good light reflection, and as well as a high light transmission? This research method is quantitative in nature, and in this research we're going to use a bunch of formulas to figure out the heat absorption, the light reflection, as well as the light transmission power. So for the heat absorption, we're going to use a formula called the Lambert-Bird formula, and for the light reflection, we're going to compare the light intensity before and after the reflection. And for the light transmission power, we're going to find the ratio between the intensity of the light transmitted and the light incoming. In this research, there will be three variables, which is the independent variable, which includes the sample 1 and sample 2, the control variable, which is time, and lastly, the dependent variable, which is the light intensity, temperature, and the amount of light reflected. The tools we're going to be using for this experiment is a ruler, a room thermometer, a cutter, a board marker, lux meter, as well as a protector. The material consists of two samples. Sample 1, which is a droplet protection cover using just a polymethyl methacrylate, and sample 2, which is a droplet protection cover with polymethyl methacrylate, and it uses a polyethylene terephthalate filter applied to it. As you can see from here, this is our research step. So our research steps start with preparing the tools and materials needed for this research. After preparing the tools and materials for the research, we're gonna design the sample, which is the droplet protection cover with and without the polyethylene terephthalate filter. After designing that, we're gonna measure the variable, which is the heat absorption, the light reflection, as well as the light transmission power. After measuring the variable, we're gonna insert the data from our observation into the graph. After that, we're gonna analyze the graph and we're gonna make a conclusion out of it.
And here are the results. As you can see from the results, we can see that sample 2's heat absorption, light reflection, and light transmission is higher than sample 1's. This is because the PET filter absorbs the light that is reflected to it, making the inside of the cover darker than the outside. The filter also absorbs the heat carried by the light, decreasing the temperature inside the cover.
The first variable we're going to analyze is the heat absorption. So as we can see from the graph here, the heat absorption in the sample 2 with the polyethylene terephthalate filter is higher in every sun angular position compared to the sample 1 without the polyethylene terephthalate filter. The second variable we're about to analyze is the VLR, or the visible light reflection. So as you can see from the graph here, the sample 2 has lower VLR, or visible light reflection, in all sun angular position compared to sample 1. Lastly, the third variable we're going to analyze is the VLT, or the visible light transmission. VLT, or visible light transmission, refers to the amount of intensity of light that passes through the sample. So the lower the VLT is, the better the sample is. So as we can see from the graph here, we can see that the sample 2 with the polyethylene terephthalate filter has a lower VLT compared to sample 1 without the polyethylene terephthalate filter. From here we can see that the sample 2 with the polyethylene terephthalate filter is better because there is less light passing through the sample compared to the sample 1. In conclusion, based on our research, sample 2, which is the droplet protection cover with the polymethyl methacrylate using the polyethylene terephthalate filter, has a good heat absorption, good light reflection, and as well as a high light transmission power compared to a normal droplet protection cover with just a polymethyl methacrylate and without a polyethylene terephthalate filter. We hope that scientists could develop this research of us further, and we can publish it for the general public to use and enjoy the benefits. For our future work, we will research and design a new device called the air purifier with UV light technology. So this is an air purifier which will purify the virus in the air using a UV light technology which will purify the virus in the air. So this device will be paired with our previous device from our previous research, which is the droplet protection cover with polymethyl methacrylate and polyethylene terephthalate filter. These two devices will be paired to create a better synergy and a better combination to purify the coronavirus. That's it for the presentation of our research. Thank you for thoroughly watching and listening to our presentation. We hope that the information that we have given you has helped you and is useful for you in your daily lives. We also hope that the research will be developed further so it can be turned into a reality for the general use for its benefit.